Okay, wanted to get this out today because this is going to be a little bit of a homework assignment. If students didn't solve the problem that we explored today, they needed to finish that for a homework assignment because I showed part of the solution. And if they did finish, then a great thing for the kids to do would be to explain the problem and explain their solution to their parents or to some other adult. So that's what I'd like all the kids in Division 4 to do today. But let's just review really quickly, because in our last little video it didn't come out that clear. There's some sort of technical problem. What is the criteria for a good solution? Well, number one, it's efficient, and we're going to really talk about that today, because there is an efficient way to solve the problem that we're going to do, and there are ways that are less efficient. Of course, we always want to have an accurate, reliable answer, something we can put our trust in. That our solutions need to show our thinking in some variety of ways, and they need to show our calculations. How did we get to the answer that we got? It's not enough just to put the answer. We need to trust that it's accurate, so we need to show how we got it, what our thinking was. Of course, doing this will prove that we understand. And last but not least, and this is where our estimating skills come in really handy, is we want to try and make some sense of what we have. If we were to estimate an answer or estimate a solution, would the answer that we came up with make sense compared to our estimate? And of course, we really want to go above and beyond. We want to try to find some real world connections for this. So we also have a couple of steps here that we want to consider. We want to figure out, what is the question? What are we being asked to do? What is the strategy that we're going to use? And that's also really important. We're going to talk about strategy today. And then how are we going to go about carrying out our plan? How are we going to make that thinking visible? And at the end, checking to make sure our answer makes sense, of course. All right, so some strategies we've been looking at lately have been to use a table or use a chart. Really helpful solution on the Cayenne Lego problem that we looked at a couple days ago. But we can also make a model, or if we can't make a model, we might want to try drawing or making a diagram. So a lot of spatial problems or problems involving geometry or area and things like this, they might require that we use a diagram to help make our thinking clear, or even to help us just find a solution. So we're going to be using two strategies today. We're going to be using making a table and a model to find a solution that's going to be efficient. So can we make small models to figure out what a big model might look like without having to build it? That's what we did today. So we had an opportunity today to play around with some sticks to build some triangles. The first triangle we built was just a triangle with one stick on the bottom right here, or in this case the top. Then we figured out how many sticks would we need to build one that had two on the bottom. And we found that we went from one bottom triangle, one stick on the bottom, we needed 3 sticks, to now when we had 2, we suddenly needed 9 sticks. So if we were charting that, we would sort of say that we had 1 stick on the bottom, but then our total was 3, and then when we put 2, our total then went to 9. When we built a model with 3, we weren't really adding to the bottom, we were adding to the side, and we ended up adding now a lot more sticks. We found that 3, we went to 18. So some kids were kind of figuring out, okay, well, did we double it, or what did we do there? Did we just add 6? But no, none of those really work if you kind of build a model with 3. And then we went further. We tried to figure out, okay, well, how many, before I give them the sticks, how many sticks in total would they need to build 4? How could we figure that out? And a lot of kids just sort of drew it in, or they drew little diagrams. They didn't go through the process of trying to figure out, well, is there a pattern that we can discover in here somewhere that would help us to find an efficient solution without having to draw or build a bigger model? So that was the challenge today. So a good strategy, of course, is to first build a model and then to use a chart, or sorry, not a chart, but a table. So our first strategy was to model it, and then our second strategy was to draw a table. So these two things together might help us discover the secret. And this is what I love about math, is that there's little secrets. There's like mysteries that we can totally figure out. there's a little bit of magic to this. And if we lose the magic by doing all kinds of drills over and over and over again, then we won't actually understand the importance of those and why those skills really matter. So today, for example, we're going to do a lot of addition, but it's disguised a little bit in this little problem. So in our model that we built, we had a triangle with 3 sticks, so we had 1 stick on the bottom, but we needed a total of 3. When we added to this triangle by putting 2 sticks on the bottom, now suddenly we needed 9. When we added again in our models, oh, my drawings are not very poor, or very poor here. When we added to this bottom here again, we went now from 9 to 18. And then when we went to 4, we suddenly discovered that we needed 30. And I don't have enough room. I guess I could draw it right here. We went to 4. We found that we needed 30. So we built these models physically, if you guys all remember. But some students sort of tried to figure a solution without building it by drawing a diagram. Now this works with small models, but what happens when we start getting a lot further down the line? Now we're getting into some models that we may not have enough pieces for. Now, more importantly, if you're an engineer or you're a builder or you're somebody who has to bring in some cost estimates of your materials, you really don't want to be wrong. And you really can't build it first and then decide what you're going to need afterwards. You probably want to give in your quote a pretty accurate description of what materials you're going to need and how much it's going to cost, and you really don't want to get that wrong. So there's a real world application here. All right, so if we were to go further now, what the students figured out is they figured out, and a lot started drawing a diagram, is we figured out that the next one here with 5 on the bottom, now we jump to 45 sticks in total. So some of the early theories that students had that we were just doubling or we were just adding a specific number, they didn't really pan out. In fact, one student thought, okay, well, if it was 9 at 2, then if we went to 4, we could just double the 9. But you see here that doubling the 9 just brings us to 18, which is nowhere near what the actual total was when we built the model. So how can we find an efficient way of doing this? We want to find an efficient way. Something that we can trust, something that we can see without having to build and draw all kinds of really, really big triangles with totals of like 8. Now the homework assignment tonight, I think, was to figure out what you would need for 12 and 15. So how can we figure that out? Well, one of the ways we can figure that out is by figuring out what's the secret. What hidden secret do we see here? Okay, if we go from 3, we see that we jump from 3, now we're adding 6. And what's the difference here from 9 to 18? Well, there's a difference of 9. Is there a pattern here? We started with 0. If we were 0, we would have added 3. So 3 and 6 and 9. Maybe it's just going up by 3s. If I add another 3 to 9, I get 12. 18 plus 12 gives me 30. Here, 9 plus 9 gives me 18. 3 plus 6 gives me 9. And we can see this pattern here starting to emerge. If I add 3 plus 6 gives me 9. If I add 9 plus 9 gives me 18. 18 plus 12 gives me 30. What is going to give me 45 here? Well, 30 plus 15. And we can start to see that at the bottom here, this is going up by 3 every time. So it's yielded to me its secret. The secret here in this pattern is one that is very, very predictable. So if it went from 12 to 15 and 9 to 12, I can deduce that this next one is going to go up by 18. And the next one is going to go up by 21. And the next one is going to go up by 24. And one of the cool things I can sort of see here is that in each one of these cases, if I multiply 3 by this number at top, it's going to give me what I add to the bottom. So for example, 3 times 2 is going to give me 6. 3 times 3 is going to give me 9. 3 times 4 is going to give me 12 here on the bottom. 3 times 5 is going to give me 15 here on the bottom. 3 times 6 is going to give me 18 on the bottom. So I can figure this out pretty quickly by discovering some of the secrets that we have here. So if I go forward and I figure out, well, 45 plus 18, that's 63. So you're starting to see now that our simple multiplication and our simple addition is starting to come in really handy, and we're getting a lot of practice. Also, it's much easier to do this if our mental math is really good. If I can add 45 plus 18 in my head really quickly, it's going to help me discover this quickly. But if in case I can't, I just have to remember that 5 plus 8 is 13, and 40 plus 10 is 50, so 50 and 13 are 63. So I can figure out quick ways to do my mental math. But anyway, 63 plus 21, well, that's pretty easy. That's just 60 and 20 plus 1 and 3, so that's 84. And I can now figure out that the next one, 20 plus 80, is 100, and 4 and 4 is 8, so we're at to 108. So in our problem, so now if we go back and have a look here, our problem was to figure out if we were to continue on with our chart here, how many sticks would we need in total for building bigger and bigger triangles? We wanted to figure out how many we would need if we were at 12 and how many we would need if we were at 15. Now when you write down your answer, it's really important that you make it clear. Show us exactly where your answer is, and maybe even give me a little bit of an explanation of how you went about discovering your answer. But we can see really quickly here, if we start small and we use a model and we use a table to track our results, we can discover a pattern that's going to help us figure it out once we get to bigger and larger numbers. On our problem